Hello everyone, welcome to Vision Tech Solutions channel. In this video, I'm going to show you how to configure the GLBP or Gateway Load Balancing protocol in a network, and I will show you the functionality of this protocol. First of all, I'm gonna give you an introduction about the GLBP. If you look at this topology that we have four PCs and we have four routers. In order to add redundancy and also the load balancing in the network, we can use this protocol or GLBP. Unlike HSRP and VRRP that we use for redundancy, for GLBP we can have load balancing. For HSRP and the VRRP, we can only have one gateway, so we will have a kind of active standby forwarding. So, but with GLBP we can have load balancing. So it means all these routers can forward the traffic, and we can load balance the traffic. But if we want to use HSRP or VRRP, only one router is elected as the active and the other one is a standby. So we cannot have active forwarding. But with GLBP we can have active forwarding. And the way it works, among these routers, the one with the highest priority, or if they have the same priority with the highest IP address in this network, for example R4, will be elected as the AVG or active virtual gateway. Then the active virtual gateway is responsible for assigning the virtual IP address to these virtual MAC and also IP address to the other routers in the network, and they will be the active virtual forwarder or AVF. And if you have more than four actually routers, the rest of the routers will be SVF or standby virtual forwarder, which for example in this you can see that the router with the highest priority is the AVG, is both the AVG and AVF, the active virtual gateway, which is responsible for assigning these virtual MAC addresses to the other routers in the network, and also will be active virtual forward. It means all these routers can forward the traffic, and the second highest router will be elected as the standby virtual gateway. In case the active virtual gateway fails, it will be responsible for assigning the MAC addresses. And the load balancing, of course, we have different let's say algorithms for load balancing. We can have round robin load balancing algorithm, we can have weighted load balancing. So if we give weights to some of these routers, for example the amount of traffic that will flow to, for example, router 1, if we use the weighted load balancing algorithm, will be more than the traffic that goes to other routers. Or round robin, for example, each router MAC is used sequentially to respond to the ARP requests for round robin. Or we can have also host dependent load balancing, that the given host, for example, always uses the same, for example, router. Always PC1, for example, forwards the traffic to R1 or PC to R2. This is called host dependent. So we have round robin, we have weighted load balancing, and we can have in the host dependent load balancing algorithm. And so in this situation, see that if this one fails, the active virtual gateway fails, we can have the standby virtual gateway will take charge. And in some scenarios we use like this. For example, if these hosts want to connect to the internet, so they can load balance the traffic between four routers, and in case the active virtual gateway fails, the other router will take charge. Let's jump into the scenario that we have. So I have uh, these tasks, and of course I'm using this topology. So R1, R4, and R6, and actually what I'm gonna do, I will configure the load balancing between R4 and R6, and from R1 I will test the uh, load balancing. So these three routers, and we can see that we have VLAN 146, which is shared between these three routers, R1, R6, and R4. So the task that we are going to do is to configure GLBP for host on VLAN 46 so that first hop redundancy and load balancing occur between R4 and R6. So let's talk about the scenario, and also at the same time I will explain the task that we are going to achieve. So GLBP on VLAN 146 between the host, between these three between these two routers actually, and this is representing our, let's say, client. So our redundancy will happen between R4 and R6. R6 should be elected as the active virtual gateway, AVG, and both R1 and R6 are used as active virtual forwarder. So this one should be active virtual gateway and both should be active virtual forwarder. The IP address of the virtual IP address, they should use 155.1.46.252. 1 second hello interval and 3 second hold time should be configured, and we have to distribute the traffic load between R4 and R6 in 2:1 ratio. See, so there's 2 packets go to R4 and 1 packet should go to R6. So it means we are using the weighted load balancing algorithm. And we also need to use authentication with the password of Cisco. So that is the tasks that we are going to do, and this is our topology. I'm using the EVNG. I'm using actually the CSR 1000V on, and we have these 3 routers. So I'm going to do the configuration. As you can see, show IP int brief. So we have the gigabit 1.146, and on 4 also I have so we have VLAN 156, which is shared between these 3 routers. Okay, so we have to configure the load balancing between R4 and R6. So I will go to router R4, look at our tasks again. So GLBP on VLAN 4 so that the first hop redundancy and load balancing occur between when we say both load balancing and the first hop redundancy, it means we are going to use GLBP, because we can have first hop redundancy with HSRP or VRRP, but for load balancing to happen, we need to use GLBP. So what I'm gonna do on router R4, I go to gig 1.146 because I want to do the load balancing and redundancy on VLAN 146. I issue the command GLBP 146. This is the group number. I use the IP, and the IP, as I mentioned, the IP that we are going to use is this one, the virtual IP address. And also keep in mind that R6 we have to it should be active virtual gateway. It means we have to change the priority on R6 when we are configuring it. Okay, first we are going to start with 155.1.46.252, and because also if you look at the other requirements, the hello interval and the hold interval should be, the hello interval is 3, the hold hello should be 1 second, and the hold should be 3 seconds. So the way we configure this, GLBP timer, GLBP 146 timers, 1 for the hello and 3 for the dead. Also, I want to use the preempt, so in case the active virtual gateway, which is R6, fails, it should take charge. So another requirement was to have the load, it should be 2-1, so it means R4 I should give a higher weight. So what I will do, GLBP 146 weighting, I use 20. I also use the 146 name VLAN 146, and because I want also to use the authentication, so I use GLBP 146 authentication MD5 key string with the key string Cisco, and GLBP 146 I'm going to use the load balancing method of weight. That was the configuration on R4. Let's go to R6 1.146. So I use the GLBP 146 and the IP address 155.1.146.252. GLBP 146 timers, hello and dead 3. GLBP 146. So here, because I want to use the R6 as the AVG or active virtual gateway, so I use the priority, the default priority is 100, so I use 110. I use GLBP 146 preemption, GLBP wait 146 waiting, I use 10, and GLBP 146 name VLAN 146, and GLBP 146 authentication message digest key string, we use Cisco, and GLBP 146 load balancing weighted. So that was all the configurations that we need to do on these two routers. So if I go now to and show GLBP, so as you can see, it shows the group number and it shows the state is standby, because the active virtual gateway is now R6 based on the priority that we have set. And there are also two members. These are the group members that we have 4 and 6, or 4 and R6 in the GLBP, and the we have forwarder 1 and forwarder 2. Forwarder 1 in state is listen, and forwarder 2, this is the active primary as it shows here. So the actually the active virtual forwarder in fact is a virtual gateway consisting of the primary and backup physical gateways. So if I go to now R6 and I issue the same command, show GLBP, and you can see that this one is the active. It means it is the AVG, and also it is the AVF or active virtual forwarder, because both now are forwarding the traffic. So now if I go to, I want to do the verification. See, if I go to R1 and I ping 155.1.146.252, which is the virtual IP address. Okay, and now if I go show IP ARP 155.1.46.252, so it is showing this this MAC address. Let's go and see what is this MAC address for which of these. So it is 007 B44492001. So if I look at the GLBP and R6, I can see that. So we have, this is for one of the forwarders, and this is for the other forwarder. So if I go to R4, so 9202, and this is 9201. So 9201, let me check. And here, this is 9201. This is 9201, and which is sending here. So 9201, this is the forwarder 1. So actually it is forwarding to this router, and this is the forwarder 1 with this owner ID is 00C. So if I check that which one belongs to this one, so 00C 293A, this is, so it is sending to R4. So it is sending to R4 because R4 is active virtual also forwarder. So now if I let's do this, because the next time, and R4, as you know, 2 packets will be sent to R4. The traffic share is 2 to 1, so it means 2 packets to R4 and 1 packet to, that's why now it is sending to R4. Now if I just to show you, we can also do or let's say clear our cache. and then I go on the int gig1.146 shut down and no shut, and do ping again 155.1.146.252. Do show ARP cache, show IP ARP, sorry, do show IP ARP 155.1.46252. So if you look now, it is sending to 02. See, previously it was sending to 9201, now it is sending to 9202. So if I again do clear our cache, shut down, no shot, and ping again, and let's see, show IP ARP. Now it is again sending to 2. So every time like 2 packets to R4, and I showed you that this one belongs to R4 because this one so if you look at this 9201, so 9201 is the forwarder 1, and the owner is this MAC address, and this MAC address belongs to R4. So 9201 with this MAC address, and this is the virtual actually MAC address, but the owner is the physical MAC address of R4. So with this verification, we saw that the traffic is load balanced between R4 and R6. Also, if I show GLBP brief, so as you can see that we have active forwarder, we have the other one is in the listen state, and we have one standby, which is the, as you can see, the virtual MAC address. So the active router is this one, this actual AVG or active virtual gateway. If I go to show GLBP brief, also it is showing that this one with this priority is the active router, active virtual gateway. So with this verification, we saw that with using the GLBP configuration. So if I show run int gig1.146, so this is the configuration that we can use to configure the GLBP on router 6 on this VLAN or on this interface, and the same 1.146, the same configuration, and the GLBP was working and it was load balancing the traffic, and also it was using the authentication, and the traffic share is 2-1. It means 2 versus 1, 2 packets to R4, and it is we are using the weighted load balancing algorithm. So I hope this lab has been useful. If you found this lab useful, please don't forget to like and to share it with your friends. Thank you very much. See you in the next video.